Hello everybody, here we have a point with coordinate x comma y on a unicircle. This angle will be measured with theta, and I can relate x, y, and theta with the following. I know that sine theta is opposite over hypotenuse, which is y. Cosine theta is adjacent over hypotenuse, which is x. Since this is a right triangle, I know that x squared plus y squared is equal to 1 for the unit circle. And substituting the values in for y and x, I get sine squared theta plus cosine squared theta is equal to 1. And here we have our first Pythag identity. Okay, now for the second Pythag identity, I'm going to take this equation and divide both sides by cosine squared theta. What I get is sine squared over cosine squared will give me tangent squared theta, plus cosine squared over cosine squared, that's just 1, equals 1 over cosine squared, that is secant squared theta. And here we have our second Pythag identity. For the third Pythag identity, I'm going to take this equation, and instead of dividing it by cosine squared theta, I'm going to divide it by sine squared theta. Okay, and what I get is sine squared over sine squared is 1, plus cosine squared over sine squared is cotangent squared theta, equals 1 over sine squared is cosecant squared theta. And here are all three of our Pythag identities. Okay, now let's go over the sine and cosine sum and difference formulas. Here I have constructed a rectangle, and I have inscribed right triangle DEF with hypotenuse length 1. I have labeled this angle alpha and this angle beta here. So AFD should be the same as FDC because these two are alternate interior angles, with AB being parallel, DC being parallel, DF being the transversal. So therefore AFD must be alpha plus beta. DEC, this angle, will be complementary to alpha, so this will be 90 minus alpha. Since this angle is 90 degrees, this angle must also be alpha, so that alpha plus 90 minus alpha will give 180 for this straight angle here. All right, now let's get into the meat of it. So if I look at beta, I can take the sine of beta, and this must give me FE over DF. So FE over DF, which is 1. So FE is simply sine of beta. If I take the cosine of beta, this will be DE over DF, which is simply DE over 1. We found that DF has a length of sine beta. DE has a length cosine beta. If we look at alpha, we realize that if I take the sine of alpha, this will be exactly the same as EC over DE. So EC over DE, which is cosine beta, solving for EC. EC gives sine alpha cosine beta. I can also take the cosine of alpha. This will give DC over DE, which is cosine of beta. And I solve for DC. DC is equal to cosine alpha cosine beta. So let's label these in. Now let's look at this right triangle on top here, this little one, EFB. If I take the sine of alpha here, this must give me FB over FE, which is sine of beta. And I get that FB is sine alpha sine beta. If I take the cosine of alpha in this triangle, I get that this is EB over FE, which is sine of beta. And we solve for EB, getting sine beta cosine alpha. Let's also label these two lengths in. Now we are interested in sine of alpha plus beta, which is the sum formula, and cosine of alpha plus beta. So let's take the sine of alpha plus beta. This must be equal to AD over DF, which is 1, so just AD. Now let's look at AD. AD is the other length of the rectangle, and BC is on the other side. So this means AD must be equal to BE plus EC. BE, we found out, was sine of beta times the cosine of alpha. EC is the sine of alpha times the cosine of beta. So let's write out our angle sum formula for sine. And here we have the sum formula for sine. To get the sum formula for cosine, let's just take the cosine of alpha plus beta. This is equal to AF over DF, which is 1. Now, AF must be the length of DC minus FB. So, DC, we found out, was cosine alpha, cosine beta, and FB was minus sine alpha, sine beta. And here we have the sine and cosine sum formulas. Now let's try to get the difference formulas. To get the difference of angles formula for sine, let's pretend that instead of this was being alpha plus beta, we have sine of alpha plus negative beta. Now this would give sine of alpha minus beta, but we can still use the angle sum formula to evaluate this. We know that cosine is an even function. This means cosine of negative x will be cosine of x. So this simplifies to cosine alpha, cosine beta. We know that sine is an odd function, therefore sine of negative beta will be negative sine beta. So I'm going to move the negative to the front. Minus cosine alpha, sine of beta. And here we have the formula for the difference of angles. To get the difference of angles formula for cosine, instead of having this as cosine of alpha plus beta, I'll have alpha plus negative beta. Replacing everything in the equation, we get this equation right here. And so, if I look at this, cosine of negative beta will be cosine of beta because cosine is an even function. Minus sine of alpha, sine of negative beta will be negative sine of beta. That's an odd function. And so negative times a negative will be a positive. Sine alpha, sine beta. And here we have the formula for the difference of angles for cosine. Here I have summarized all 4 of our formulas. For sum of angles of sine, if it is alpha plus beta, it'll be sine cos plus cosine. If it is alpha minus beta, it'll be sine cos minus cosine. The two signs are the same here. For cosine, if I have angle addition, alpha plus beta, it'll be cos cos minus sine sine. That's why the minus is on top. If this is alpha minus beta, it'll be cos cos plus sine sine.